Hello everyone. So let's talk about today's Geeks for Geeks problem of the day. So problem name is smallest range in K list. K list. Okay. The difficulty is hard, but it's not actually hard. It's a medium level. But if you solve a similar problem already, then it's easy for you because you think in that direction. But let's see if you don't solve any problem. Let's see. I will make it medium level at least. So let's see what is given in a problem statement. So we have given an 2D integer array of a size k into n, where each row is sorted in ascending order. Your task is to find the smallest range. Our task is to find the smallest range, which is LNR, that includes at least one element from each of the k list. If more than such ranges are found, return the first one. Okay. So let's see what the problem statement are saying. Now you have given n k into n grid, means the k rows and n columns. This is n k into n length, the size of this k into n. Now what they are mentioning, you have to find a range left and right, left and right. So consider you pick us 0 and 6. So how many you pick a random range, okay, any range. So 0 and 6, I pick just 0 and 6. So one, or how many element between this range, 3, 4, 5 and 6. Now you have to check uh, the list element. Each of the k list, at least one element present in the this list, at least one element present. So let's see, in this 4 is a present, from this list 0 is a present, and from this list 6 is a present. Now what is the length of this list? Range is a 6. Okay. Now what is given in a problem statement? Answer is a 6 and 8. Okay. So let's see what is 6 and 6, 7 and 8. Okay. So this is an another range where L is equal to 6 and R is equal to 8. Okay. Let's see how many elements are present. So in this range from each list, so 7 is present. Okay. Then 8 is present from this list, and from this list 6 is present. Okay. And what is the length of this list is 2. So it is lesser than previous. So you have to make smallest possible range, and where each of the element means at least one element from the each list present in the array, at least one element from each list present in that range. Okay. Let's see, if I just take a 1 and 3, 1 and 3, so how many element? 1, 2 and 3. Let's see. So there is no element present in a 1 from first list. So there is no any element from the first list present in this range. Okay. So this is not a valid range. Okay. But if you take just a 4 and a 9, let's see, 4 and 9, it is a 9 and it's a, let's see, you just pick a 4 and 9. So the first element is a present 4, 7, 6, sorry, 4, 6, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8 and 9. Okay. The first element present, second also present, and 9 also present. So from first list there are 3 elements present. Okay. In a second list only one element is present, and the third list only one element is present. So this is an valid range. But what is the length of this range? Is a 5. So you have to pick a minimum range as much as possible. Okay. So this is given in a problem statement. Now how you find this range? Let's try to understand. Let's try to understand. Let's apply some intuition to understand this range. So let's see. We are looking the previous example is as well. So what I am saying, why I am starting, what is the worst range? What is the maximum range we can found? This is a 0, and what is the maximum number? So L is equal to 0 and R is equal to 50. It will include all the element from the list. Why I am taking? I am taking a minimum element from the array, means minimum element from the array and maximum element from the array. So it will include all the element within the array. Okay. So this is a maximum range. Now you have to minimize it. So what I'm saying, let's see. I'll just go a sum, as I know the sorted array. So I'll try to make all the possibilities with a sorted. Okay. So in a first time, I'll just start with the first row, and sorry, I'll just start with each column. Okay. Because I have to pick the k list. So what I'll go with column wise. So in each column, I'll just pick minimum and maximum value. Let's see. So it will become a 0 and it will become a 6. Okay. So what is the range? What is the length of this? The 6. And element are already present because this all 4, 0, 4, 5, 6. So it already present. Why I am saying this? Because I am taking a minimum from the all the columns. As I am going a column wise, this means each list element will be present in that range. Okay. So if I go to the next column, what is the minimum here? Is 7 and 12. Okay. 7 and 12. But that is the optimized answer, what I am saying. Because if we go with the 7 as a minimum and 12 as a maximum, but our answer, which is given in example discuss, is 6 and 8. So we are missing 6 in the previous set. So I have to keep track on the previous set. Now what I will do? So now what I am saying, as I found a 0 as a minimum element, I'll try to get next of that 0. Okay, there might be some chances the element is maximized, the element will be maximized, then difference will be minimized. Okay, what I'm saying, if the element, if the number is maximizing, then difference will be smaller. Suppose what I'm saying, 0 and 6, the difference is 6. Suppose this 0 go to the 2, 1 and 6. So what is the difference? Difference will be 5. So this, if this element is increasing, then difference will decreasing. So what I'm saying, I'm just going, and I'm what, as in 0 is in my first range. So I just go to the next element. Now I include this. Now I just say, just let's check if this is a minimum. Let's try to get the next element of this. There might be a chance it will uh, increase, it will just a little increase by a maximum number, smaller than the maximum number, and the difference will be minimized. Let's see what I'm saying. Let's understand what I'm saying in the with the dry run example. Okay, so it will become 8. Now I have left with the array where my first element is in this, second is this, and third is this. Okay, because I already included 0. Now I have to pick the minimum and maximum amount for these three. So what is the minimum? The minimum is a 6, 4. Okay, the minimum is a 4, and what is the maximum? Maximum is a 8. Okay, now what is the difference? Difference is a 4. Yeah, difference is minimized. But now if I just pick this 4, what I'll do, I'll just try to go next to this 4. Why? Because if the element is increased, then difference will decrease. Okay, now I have to get minimum maximum from among these three elements. Now what is the minimum here? The minimum here is 6. Okay, and what is the maximum? Maximum is 8. What is the difference? Difference is 2. So this might be an answer, but we'll go next. So as I include the 6, I'll go to the next. Now I left with these three elements, 7, 8, and 12. So I'll just pick the 7 and 12 as a maximum and minimum. What is the difference between these three? So 7, the answer is a 5. Okay, so this is not, so till now my answer is a 6 and 8. Okay, because the difference is greater than this. Okay, no issue. So let's see, as in my minimum is a 7, so I go here. Now what is the minimum? So this will become, I have to just pick amount from these three, like, okay. So what I'll do, I'll just take an 8 and 12. So what is the difference? The 4. Okay, so it is also greater than this difference, so I'll just go to the next of these. So I'll go here, I'll just cancel out it. Now it is 9 and 12. So what is the answer? The answer is a 3, but it is always, it is greater than this, so I won't change the answer. I'll just go to the next of these. So I'll just cancel the 9, and this will become this. So what is the next range I get? The next range I get is a 10 and 12. What is the difference? The difference is 2, but this is similar to this. The problem statement already mentioned, if you find a multiple distance, then return the first one. So what is the first one? First one is 6. You don't need to change, even these are both are the equal. So this is all about the problem statement. Now how I will solve this problem? Now this is the problem coming in my mind. Now I understand I can solve in this manner, but how I will solve? So what I am saying, I'll use a min heap, because I have k listed. Okay, k list, and I have to pick a minimum among all the list, and I am discarding that minimum. Okay, I have k listed. Okay, I have to pick minimum among k listed, and what I'll do, as I use this minimum, I am discarding it. Correct, we are doing this thing. So if I am doing all this thing, and I already solved the one problem, the merge k array, you have to also solve this problem. You can easily understand this problem. This is your homework. I'll show you the problem link. I'll give you the problem link in the description. Okay, so we have k list, we have to find a minimum among k list, and after using that minimum, we are discarding it. Okay, now what about the maximum? What about the maximum? How I will track the maximum? So as I am inserting the k values in my heap, min heap, as I am inserting the k value in min heap, what I will do, I will just update the max. While inserting, I will update the max. Okay, let's see with the dry run, and once we dry run the example, you will understand what I mean. So we'll take a smallest example. So okay, now 1, 2, 3. Okay, so there is a 2, 4. Then what is this? 2, 4, 1, 7, and 20, 40. 1, 7, and 20, and 40. Okay. Now what you have to take in a min heap? So what I'm saying, so let's see, create an k size min heap. Why I'm saying k size? Because I have to just insert a k values. Okay. So let's see. So the just taken k size min heap. Why it's not working? Okay, my bad. Okay. So k size min heap. Okay, a 1, 2, and 3. Okay. Because I have now the first is will take a minimum value because I have to take a value. So it will take a value which is actual array value. Okay. Now I don't know which is array I am using. So the number of array means which array I am using. So row value, so row count, which row is this, and which index element. So I'm just taking the idx as an index element. So I'll take these three. Now I will insert all this element and I'll just keep the max value as an my global variable or local variable outside the loop. Okay. So initially max value is in 0. So I am just inserted 2. So I inserted 2 with an row 0 and value is index is 0. Okay. Now I come with a 1. 1 is smaller than this, so it will insert it here. So I'll just take this here and I'll just take 1. Okay. Now what is the my max value? 2. While inserting, I'll updating the max value. Now come 1. 1 is smaller than 2, so my max value will remain 2. Okay. Now I see 1. What is the row of this one? Is a 1 and index is 0. Cool. Now I increase the I'm inserting a 20. While inserting, I'll update the max value. So 2 will become a 20 now. And where inserted in heap, it will insert in end. What is the row? Row is a 2. And what is the index? Index is 0. Now what just pick? You have a maximum value and minimum value you found in the top of the priority queue. Okay. So what I'm saying, let's go with the dry run. Okay. So what is the difference between these two? So the distance between 21 and 20 is 90. Okay. So your L is this and so what is the difference? Difference is a 19. Okay. Now what I will do, I'll discard this and I'll insert a next of this index. So as I'm discarding this element, what I will insert? I will insert 7 and 20. How I'll get index plus 1. Okay. I'll get index plus 1. Okay. Now let's see what I'm saying. What is a zero index in a first row? So first row zero index. This is 0, 1, 2, and 0. First row zero index is 1. Now first row first index is 7 because I'm inserting the next of this row. So let's see what is the value. Value is in 7 and index is 1 and row is a 1. Okay. So 7, 1 row and 1 index. So let's see. Your max will update. No, it won't update. So I will insert. So while inserting, it will go to the second time. So because I have 2 as a minimum, so I'll just keep this in here and 7, 1 and 1. Okay. Now correct. So let's find the difference between the minimum and maximum. Maximum value is a 20 and minimum value is a 2. Okay. So let's find the 2 to 20 range is an 80. Okay. Now same thing for the other. So the 2, I'll insert the next value of this 2. So it will insert it at 4. So to 4 will insert here. The values and index will update it here. Now let's find the distance between these two. The 4 and 20, the distance is 16. Okay. Now as you find a 16 as a distance, so 4 and 20, the distance will be the 16. Okay. Now I'll try to insert the value to the next of this element, but there is no index, so it will get discarded. Now, as it will get discarded, I have left with only 2 values, but I have to keep track of the 3 values. Okay. So can I say this is row is the smaller among all this value? Means this value is the smallest among all the remaining value. The 4 is the smallest among all the remaining value. What are the remaining value we have? 7, 20, and 14. So this value is the smallest among all the value. So I can say if my heap size is less than k, then I'll stop the operation. Until it is equal to k, I can do. It will never go to the greater than k. Why I'm saying? Because I am taking only k size. So if it is equal to k, I can do the operation. But if it is less than k, so what I will do? I'll just discard the operation. Means I won't do the operation. Okay. So this is the problem intuition, and this is the all idea working behind it. So we can use a min heap, and we'll find the maximum values while insert into the min heap. So what I'm saying, min heap for the finding and minimum difference, minimum value. Okay. Maximum value will insert max value when we find while doing the inserting in a min heap. Okay. We'll find a difference and we'll stop when the heap size is less than k. We'll stop here. Okay, so let's try to code it out. If we can pass all the tests, let's discuss the time and space complexity, and after that, so we have to take a three values. So what I'm saying, I'll just create a priority queue. Priority queue. Okay. So I have to take in three values. So what I'll do, I'll just take a tuple of integer, comma, integer, comma, integer. Okay. But instead of this, I'll just define it here. Hashtag define ti as tuple. On, I'll just keep this here, integer, comma, integer. So it will make it easy. Okay. So ti and then vector of, I'll defining a min heap. Okay. Greater and ti. Okay. Okay. Let's see for int I is equal. Oh, I have to define n is equal to array dot size. Then where is the k list? Integer k is equal to array dot size, and n is a column. So I'll just take a 0. This is for okay. Now I'll insert a first. Also, I have to take a maximum value. Max value is equal to 0. Left is a -1 and right is a -1. Okay. Integer minimum difference, which is int max. Cool. So let's see. I'll just start with the 0, I less than n, and I plus plus. PQ dot push. Now these are the tuple. So I'll just make tuple. Okay. Now what I will insert? First I'll insert the array of I, comma 0, the first index, and then after that row. So what I'm saying, the tuple, the first will be the inserted in a tuple. The first is a value, then row, and then column. Okay. Or I just say index. Okay. So what is the row? Row is an ith row, because I'm starting with the k. I starting to 0 to k now. So and what is the call index? Index is 0 for each, and I have to just find a maximum value while inserting. So max of max value and array of I, comma 0. Now pq dot size is equal to k. I'm doing the operation when my queue size is means my heap size is k. Okay, I'll find a value which is I get from 0. So get 0 of pq. Okay, now integer idx. So row which get from the 1 of the pq dot top. Okay, means why top? The top is a tuple. Okay, and integer idx. Idx will get from get. So here is a 1. Get 2 of pq dot top, and I'll do pq dot pop while extracting all the value from this row. Okay, so this is an tuple. This is an tuple. So this is an tuple. So it will lie on a pq dot top. Okay, so you and from extracting from tuple you use the get and the index and that tuple name. Okay, so this is a tuple name. So this is an tuple. So that's why I'm using this syntax. If you don't know tuple, you can read about it. It's very easy and it is very helpful. So now what I'll do, I have to find a difference. Integer difference is equal to max value minus value. Okay. Now if difference is less than minimum difference, what is minimum difference? So you have to just update a L with value, minimum value, and R with a maximum value. Okay. After that you have to update your difference. So min difference is equal to diff. Okay. And you have to just insert the next value. So what I'm saying, if idx plus 1 is less than n, why I'm saying, because there is an index left. Okay, let's see here. Because this is an first index. This is an first index. Now there is no second index. So how I'll insert the 2? So that's why I have to just check. So what I'll do, I'll just pq dot push make tuple. Now you have to insert array of which row and what idx plus 1 value. Now what is the row and then idx plus 1 means you have to just update it. Now once you update the value, what you do, you just update the maximum value as well. Now which value you are inserting? idx plus 1. Okay, so you'll update this and just return the L and R. Okay, so let's see if it is passes all the test cases. We'll discuss the time and space complexity. If it won't get passes, then we'll try to fix it out where it given the wrong answer. Okay, so it giving the segmentation fault. Where it giving the segmentation fault? Okay, let me check what I'm doing wrong. Pq dot size. Okay, then if idx plus 1 is n, okay, so value is gate of 0, gate of 1, and pq dot top, pq dot top, pq dot top, top. Okay, so pq dot size is the same. Okay, priority queue. Integer n is array dot size, k is equal to L minimum value. I is equal to 0, I is less than I plus plus. Okay, nice. This is also correct. Then pq dot pop, gate 0, gate 1, gate 2. Okay, so row. Yeah, the value is also correct. Array of row and idx plus 1, then array of idx plus 1 and 0. Yeah, these all these test cases are correct. Then why this is giving me the wrong answer? Let me check where I'm doing wrong. Again, I'll just check. Okay, then 0 to k, and I'll go to the kth row. Okay, correct. So I have only k row. So I'll just do. Okay, so n columns and the k row. Okay. Now this is an the gate 0, which is the gain the value. It will give me the row. It will give me the again value and pq dot. Okay, I'll just calculate this. Now idx plus 1 is less than n. This condition is satisfied. Just make a table and insert into idx plus 1 row and idx plus 1. Okay. That's all this correct. I'm looking these are all are correct. So you should don't give the TL. I'll just ask the bot what I'm doing wrong because I'm not funded with that. Okay, maximum value is equal to max value on array of idx plus 1 and 0. Okay, my bad. There is not idx plus 1. Here I just have to insert the row and then idx plus 1. My bad, my bad. I won't change this. Sorry. It's happened sometime. You just come with any silly error. Okay. Yeah, so it passes the example test cases. Let's check with the if it is passes all the test cases, let's discuss time and space complexity. If it won't get passes. Okay, so yeah, it is getting passes. Okay, so it passes all the test cases. So let's see what is the time complexity of this. So we are using a queue which will take a big of k size because we are only inserting the k values. So the space complexity here is a big of k. Now we are iterating on the entire queue. Okay, we are iterating on the entire array on an n size. So it will take an n size. Why I'm doing this? Because inside an queue, I'll iterating on the entire n array. Okay, while inserting on queue, we'll just take a log k operation. Okay, log k operation. So n into log k. But okay, that's the time complexity, and this is the space complexity. So while inserting, you'll just take a log k, and you are iterating on the entire column wise because you are iterating entire column. And how many times you are doing this? You are doing this k time. Okay, your size is a k. Your k into n into log k. So this is the time complexity, and the space complexity is while inserting you are just taking a log. Okay, size of the k. We are iterating on the k size array. No, we are not iterating entire k because we are just going with the k. So we'll just b of n into log k. But once the k is becoming less than this, so you just stop the loop. So you are not iterating entire k list. So this is b of n into log k. Uh, and this is the time complexity and this is the space complexity. So this is for today's. Let's meet tomorrow with a new problem set. Bye.